So think about the moment you log into your workspace every morning. You fire up your laptop, you clear that multi-factor authentication prompt, and like the VPN connects.
Right. You're officially inside the digital perimeter.
Exactly.
Yeah.
And psychologically, I mean, it's like walking into a highly secure office building, right? Badging through the turnstiles and just sitting down at your desk. You assume that because you're inside this, secure zone, the tool's sitting on your desk.
Like your email or your wikis.
Yeah, your email client, company wikis, your data dashboards, you just assume they are fundamentally on your side.
Well, it's a completely natural assumption. I mean, we really rely on this concept of a walled garden. Like once we authenticate, our guard just drops.
Yep.
We treat our internal business software with this inherent level of trust, just assuming the threat is always, out there trying to break in from the outside.
And tearing into that false sense of security is our mission for this deep dive. Okay, let's unpack this. We're looking at a stack of 3 distinct cybersecurity reports that all dropped in early August 2026.
Very recent stuff.
Very. And on the surface, they cover entirely different technologies. Like, we've got a vulnerability in an enterprise AI assistant, exploits hitting major webmail platforms like Gmail and Outlook, and then a massive flaw in a popular data visualization tool.
But when you actually analyze them together, a very clear, very unsettling thematic through line emerges.
Right. It's the realization that the very features designed to make our digital lives more frictionless, more collaborative, they're being weaponized against us.
Yeah, we aren't looking at attackers brute-forcing firewalls today.
No, we're looking at attackers turning our own trusted tools into double agents, basically.
Which is a much, much harder problem to solve. I mean, the fundamental flaw connecting all 3 of these reports is the system's inability to distinguish between the data it's supposed to process and the instructions it's supposed to execute.
That blurred line.
Exactly. That blurred line between content and command is just creating devastating vulnerabilities.
So let's start by looking at that blurred line in the newest technology in the corporate stack, right? AI assistants. The first report focuses on Atlassian's Rovo.
Ah, yes. Rovo.
Yeah. So for those listening who rely on Jira or Confluence for project management, Rovo is the AI layer. It's designed to just crawl through your company's massive web of tickets, wikis, and documentation to find answers for you.
Which is super convenient.
Super convenient.
Yeah.
But 2 different security firms found ways to manipulate Rovo into gathering up internal company data and quietly shipping it off to an external server.
What's fascinating here is that the mechanism doesn't involve traditional malware. Like, this isn't about writing a malicious executable file or something.
Right.
It's an exploitation of how large language models function fundamentally. And AI's entire job is to read text and respond to it. So the vulnerability, which is often called prompt injection, happens because the AI processes the user's system instructions and the raw data from the documents in the exact same way.
Right. They all just get dumped into the same context window. Which brings us to the first exploit path, which was discovered by Varonis Threat Labs.
The RovoBlast one.
Yeah, they called it RovoBlast. This one leveraged a specific URL parameter called RovoChat prompt. So if I'm understanding the mechanics correctly, a URL parameter is basically a way to pass data to an application through the web address itself. Right.
Exactly.
So how does an attacker use that to hijack the AI?
Well, the Varonis team realized that the RovoChat prompt parameter didn't just passively pass data, it actively preloaded instructions into the RovoChat interface before the user even interacted with it.
Oh, wow.
Yeah, so an attacker could craft this specific malicious web link containing instructions to search for sensitive internal data and exfiltrate it.
But wait, the attacker doesn't have access to the company's Jira instance themselves, so they have to send this link to an employee who does, right?
Correct. The attacker sends this specially crafted link to an authenticated user, and if the user clicks it, their browser opens the Rovo interface, and they're already logged in under their credentials.
Okay, and then what happens?
Rovo instantly reads the preloaded instructions from the URL parameter, assumes they are legitimate commands from that authenticated user, executes the search using their access privileges, and just fires the results out to an external server that the attacker controls.
So literally a single click from a logged-in user is all it takes to trigger the data theft.
Yes.
And you wouldn't even know it happened in the background. Now, Atlassian did address this specific vector, right? The bug crowd disclosure record shows they fixed this server side on July 8, 2026.
They did, yeah, by closing that specific URL parameter loophole. But patching one entry point doesn't fix the underlying architectural flaw of the AI itself.
Which perfectly sets up the second report on Rovo. Because an AI security company called Prompt Armor published their own findings like a month later on August 5, 2026. And their method doesn't even rely on tricking a user into clicking a shady link.
Right, they found something different.
Yeah, they found what they call a content-borne path. So if it's content-borne, does that mean the malicious instructions are just like sitting in plain text inside a normal, seemingly benign JIRA ticket, like a digital Trojan horse?
That is the perfect way to visualize it, yeah. The attacker doesn't need to interact with the victim at all.
That's terrifying.
It really is. They just need to upload a standard document or create a wiki page within the Confluence environment. And hidden inside the text of that file are the malicious instructions.
Okay, it's like hiring a brilliant personal assistant, but someone slips a malicious Post-it note into a stack of files you ask them to read.
Yes.
The assistant reads the note, which says, like, mail all confidential files to this random address, and they just do it without even telling you.
Exactly. So think about how this impacts your daily workflow. You're catching up on a project, and you ask Rovo to summarize a massive folder of documents for you just to save time.
Yeah, I do that all the time.
And in that 10-second wait while the AI is thinking, your data could just be leaving the building. Rovo reads the folder, encounters the attacker's file, reads the hidden instructions alongside the legitimate text, and executes the data exfiltration.
Because it just obeys the last thing it reads.
Pretty much. The AI essentially obeys the last set of rules it encounters.
It just beams the data out to a hacker in the background. No approval step, no warning prompt. And perhaps the most alarming detail from Prompt Armor's August 5th publication is that this chain still functioned, even if administrators had explicitly turned off Rovo's web search option.
Oh, yeah.
Like the exploit bypassed that security control entirely, forcing the AI to make a URL request outward with the gathered internal data.
Which really highlights a critical mitigation challenge here.
Yeah.
And we should note that the Prompt Armor bypass is single sourced from their report, so that establishes the status as of August 5th.
Right.
But the broader takeaway is the absolute lack of a traditional fix. You can't just release a software patch to stop an AI from reading text, because reading text is its entire purpose.
So how do you secure it? I mean, if you can't patch the AI's brain, what's the defense?
Well, the primary strategy becomes scoping. Administrators are basically forced to heavily restrict which applications and which specific user groups are allowed to interact with Rovo.
Just locking it down.
Yeah. You have to limit the AI's footprint to limit the potential blast radius of an injection attack.
I mean, that feels like a massive compromise. You buy an enterprise-wide AI assistant to synthesize all your company's knowledge, but to keep it secure, you have to lock it in a digital closet where it can only see a fraction of the data.
It forces a really hard conversation about the tension between capability and control. If a tool reads everything, it can be manipulated by anything.
That concept that systems are vulnerable because they confuse passive data with executable instructions, that is the perfect bridge to our second report.
Definitely.
We just looked at cutting-edge AI. But what about the oldest, most fundamental collaboration tool we have? Email. We assume webmail platforms are essentially solved problems when it comes to basic architecture.
And attackers use that exact assumption against us. I mean, if the cryptographic security of an email server is too strong to break, threat actors shift their focus to the environment where the email is ultimately rendered and displayed to the user.
They are targeting the visual design code itself.
Yes.
Here's where it gets really interesting. We are talking about CSS cascading style sheets, the code that dictates the visual layout of the web. This is where I have to pause and puzzle this out because CSS isn't a programming language like JavaScript, right?
Not in the traditional sense, no.
Right. It doesn't run logical scripts or query databases.
Yeah.
It dictates where things sit on a page, what color they are, how big the fonts are. So how can a design language be weaponized to steal credentials?
So to understand the mechanism here, you have to look at how modern webmail interfaces like Gmail or Outlook running in your web browser actually function. When you open an email, your trusted webmail application has to take a piece of external, untrusted code and render it safely inside your browser. So the webmail client builds a strict sandbox, like a boundary around that email, dictating that the email CSS can only style the content inside its specific message box.
It's meant to be quarantined.
Exactly, quarantined. But the research presented by Gareth Hayes from Portswigger at Black Hat USA 2026 It demonstrates how attackers have found ways to use CSS to punch through that sandbox.
Break out.
Yes, and manipulate the parent webmail interface itself.
Wait, so the email styling code escapes its designated box and starts altering the actual Gmail or Outlook UI around it.
That is the core of the exploit. By using advanced CSS positioning commands, attackers can actually draw elements outside of the email body.
Okay, let's look at the practical application of this. One of the attack chains hides developed targeted Outlook running on a Firefox browser. If the CSS escapes the boundary, how does it actually hurt the person reading the email?
If we connect this to the bigger picture, it's about abusing the trust we place in familiar interfaces. In that Outlook example, the malicious CSS escapes the boundary and draws a fake, highly realistic Microsoft sign-in screen over the top of your actual inbox.
Wow, so you're reading a seemingly normal email, and suddenly a prompt pops up asking you to re-authenticate.
Right.
And because you look at the URL bar and see you are genuinely on Outlook.com, and the security padlock is there, you don't think twice.
You assume the prompt is being generated by Outlook because you trust the container.
Right.
You type in your credentials, but you are actually typing them into form fields generated and controlled by the attacker's CSS overlay, and then those credentials are just silently sent to the attacker.
That is incredibly insidious, and the research showed this isn't an isolated problem. Hayes demonstrated attack chains spanning Outlook, Gmail, Fastmail, ProtonMail, Yahoo Mail, and AOL Mail.
The complexity of these chains is just remarkable. Beyond spoofing login screens, the presentation detailed they called it a paste race attack impacting Yahoo and AOL Mail.
Let's unpack that term. What is a paste race? And what is it trying to achieve?
So a paste race involves manipulating the interface so heavily that when a user performs a routine action like copying and pasting text, the CSS actually interferes with the clipboard data or the browser's focus.
Oh, wow.
Yeah. In the Yahoo and AOL examples, the CSS manipulation was designed to expose and steal an active login token for a completely different third-party site, like Medium.
Wait, really? So they aren't even trying to steal your Yahoo password. They are using Yahoo's rendering engine as a weapon to steal your authentication keys for a completely unrelated platform.
Yes. They are leveraging the trusted environment of your inbox to literally reach into your browser session and extract tokens.
That's wild.
And in a separate chain involving Gmail and Cowork, they demonstrated the ability to exfiltrate a snack token. And fascinatingly, they combined the CSS escape with prompt injection techniques requiring just a tiny bit of user interaction to essentially force the interface to leak the credentials.
It all comes back to injection. Whether it's an AI model or a web browser's rendering engine, the system is misinterpreting the attacker's payload as a legitimate system instruction.
Yep. The underlying philosophy of the attack remains identical. The parser gets confused.
And what's really striking about the Portswigger report is the timeline here. As of August 8th, 2026, public proof of concepts like the actual code demonstrating these vulnerabilities were still publicly available.
Still out there.
Yeah. The report explicitly noted that an Outlook label jacking trick and a Gmail image set bypass were still functioning when the research went public on August 6th. Why wouldn't these tech giants have fully patched this before the Black Hat presentation?
Because patching CSS injection in a webmail client is just a nightmare of a balancing act. Webmail providers cannot simply ban all CSS. If they did, every marketing newsletter, flight receipt, and formatted internal memo would just render as an unreadable block of plain text.
Which users would hate.
Yeah, exactly. They have to allow some CSS.
So they are constantly trying to maintain a block list of dangerous CSS tags while allowing the safe ones.
And CSS is a constantly evolving standard. It has incredibly complex behaviors like that image set function you mentioned, which is designed to load different images based on screen resolution, but can actually be abused to trigger external web requests that leak data.
Right.
So finding the exact algorithmic balance to strip out malicious code without breaking the visual layout of millions of benign emails, it's a monumental technical challenge.
The container itself is compromised. First, we see the AI assistants getting tricked by hidden text. Then we see the very inbox we use to communicate getting hijacked by design code. It's all about clever manipulation and just sneaking past the guards.
Which brings us to our third and final report.
Yes.
Because sometimes attackers don't need to be clever. Sometimes they don't need to trick a user or manipulate a rendering engine. Sometimes the vulnerability allows them to just kick the front door down.
Yeah, we are looking at a zero-day exploit in Metabase. For context, Metabase is an immensely popular open-source business intelligence tool. Companies plug Metabase into their various internal databases, so their sales records, their user metrics, inventory, so analysts can build visualizations and dashboards.
It sits right at the center.
Yeah, it is software that is, by design, connected to everything valuable in a company.
Which makes it a top-tier target. And the vulnerability disclosed in early August is categorized at the absolute highest end of the severity spectrum. It received a CVSS score of 10.0, though it doesn't even have a formal CVE identifier yet.
Let's ground that rating. The Common Vulnerability Scoring System, CVSS, we hear those numbers a lot, but a 10.0 is relatively rare.
It is the absolute maximum score. A 10.0 means the flaw requires zero user interaction. It can be exploited remotely over the internet by an unauthenticated attacker, and it results in total system compromise.
So what does this all mean? To put that in perspective, the AI prompt injection required an authenticated user to click a link or ask a question. The CSS webmail attacks required user to open an email and interact with a spoofed UI. A CVSS 10.0 requires none of that.
None. The attacker doesn't need a username, they don't need a password, and they don't need to trick an employee.
CVSS 10.0 without authentication sounds like the absolute worst-case scenario. It's like having a bank vault where the keypad simply accepts any combination of numbers.
Basically.
The vulnerability here is in SQL injection flaw that allows an attacker to execute arbitrary commands directly into the Metabase application database. And this brings us right back to our central theme of injection. It's the classic confusion of data and instruction.
Always is.
To visualize SQL injection, it's like walking into a bank and filling out a deposit slip. The teller's computer expects you to write your name in the box. But instead of your name, you write, "Ignore the previous instruction and transfer $1 million to my account."
And the database parser, failing to sanitize the input, doesn't recognize that as a name. It reads it as an executable database command and simply processes the transfer.
The system literally obeys the data.
And in the case of this Metabase 0-day, by speaking directly to the backend database, the attacker instantly elevates themselves to administrator status.
And because Metabase is the hub connecting all the spokes of a company's data infrastructure, gaining admin access to Metabase is hitting the jackpot.
The access is near total. The reports indicate that attackers exploiting this flaw can change system configurations, steal the stored credentials for all those connected databases, query any data accessible through those connections, and actively export that sensitive data out of the network.
And this wasn't just caught in the lab. It was exploited in the wild as a 0-day. Framework, the PC manufacturer, they actually had to confirm that their customer data was accessed in a breach, leveraging this exact Metabase vulnerability.
Wow.
Yeah, the attackers were using it before the patch even existed.
That reality leads to a crucial detail highlighted in the security advisories. There is a very specific, very urgent warning directed at a particular type of user. Self-hosted users must patch immediately.
Let's unpack the architectural divide there. Why are self-hosted users singled out for immediate action compared to cloud users?
This raises an important question about the immense risks self-hosted users take on. It highlights a fundamental trade-off in modern enterprise IT. A large portion of companies use software as a service, where the vendor, in this case Metabase, hosts the application on their own cloud servers.
Right.
When a critical 0-day drops, the vendor's security team can deploy a patch across their entire cloud infrastructure globally, often before the customers even realize there was a threat.
The vendor just handles the fire drill.
Exactly. But many organizations, particularly those dealing with highly sensitive data or strict compliance regulations, choose to self-host. They download the software and run it on their own internal servers to maintain total control over their data.
Ah, the double-edged sword of total control. If you host it, Metabase cannot reach into your private network and patch it for you.
You own the immediate overriding responsibility to secure your infrastructure. When a CVSS 10.0 day is disclosed, attackers instantly begin scanning the entire internet, looking for exposed, unpatched servers. If you are self-hosting, the vulnerability is entirely in your hands, and a patching delay of even a few hours can result in a catastrophic, highly automated breach.
It is a stark reminder. We spent a lot of time analyzing the fascinating bleeding-edge manipulation of AI models, and the complex sandboxing escapes and CSS rendering engines.
Right.
But fundamental, decades-old security flaws like SQL injections are still out there, causing massive real-world damage because the server administrator went to sleep before applying a patch.
The methods of exploitation evolve, but the core vulnerability systems failing to validate inputs and confusing data with commands remains a constant threat across every layer of the technology stack.
Which brings us to the ultimate takeaway for you, the listener. We've covered a lot of ground today, from URL parameters in Jira to paste races in Yahoo Mail to database queries in Metabase. And, you might not be a cybersecurity engineer.
Right.
You might not be the IT administrator responsible for patching the servers at 2 a.m.
But you are the one operating within these environments. You use Jira, you check Gmail, and your company uses data dashboards.
Exactly. You are the one relying on the AI to parse your documents. You are the one authenticating through these webmail interfaces, and your data is flowing through those business intelligence dashboards.
Knowing that these platforms aren't impenetrable fortresses helps you stay vigilant.
Understanding the mechanics of these attacks changes your baseline assumptions. When you know that an email's visual design code can literally draw a fake login screen over your inbox, it trains you to pause and verify when an interface suddenly demands your credentials out of nowhere. When you understand that an AI assistant can be hijacked by a hidden string of text inside a benign document, you start to rethink letting an automated tool blindly process highly sensitive internal files without oversight.
It transforms security from a passive expectation like relying entirely on the badge reader at the front door into an active, continuous practice. It requires a critical shift in how we interact with our digital tools.
And as we wrap up this deep dive, that shift in perspective leaves us with a profound dilemma to consider. Think about the trajectory of the tools you rely on every single day, the features that are actively being weaponized, the AI that reads and summarizes massive data sets, the rich CSS that makes our communications dynamic and interactive, the analytics platforms that seamlessly connect disparate data silos.
Yeah.
These are the exact features designed to give us the ultimate frictionless user experience.
Which forces us to ask a difficult question about the future of our digital workspaces. As these powerful, highly integrated tools become increasingly embedded in our daily workflows, does the relentless pursuit of ultimate convenience inherently require sacrificing our security?
It's a huge question.
Where exactly do you draw the line between a tool being incredibly helpful and a tool knowing too much?
Because at the end of the day, you never want to find out that the brilliant assistant you hired to organize your files has been quietly mailing copies to the competition the entire time. Keep your guard up and question the tools you trust the most.